Did you see this? The Andrew Karpathy tweet from, I think, a week ago, March 7th.
Yeah.
Where he was talking about AutoResearch. He was the guy who was running Tesla AI. I think he went to Stanford, if I'm not mistaken. I think he was a PhD at Stanford. He founded Stanford CS231N course, which is at this point become like the classic AI class that everyone basically
Computer
takes.
vision course.
It's the computer vision course, yeah. But it was my favorite class at Stanford. It was by far, I think, one of the best taught classes. He created that class. Then he went to Tesla. He basically bootstrapped their whole like FSD team. He left, I want to say maybe like 2-3 years ago. And then he's just been doing open source projects. It's a great life, man. I mean, it's kind of the dream, right? Yeah. So he created this thing called Nano GPT. You know about this?
Mm-hmm.
The idea is basically that he wanted to reproduce or recreate a state-of-the-art code base for training a language model. But where the gist is that all the code should be less than 500 lines of code. So like a very tiny code base so that basically anyone can tinker with this. I love that. I mean, I love this idea.
Yeah, there's no abstractions.
No abstractions.
You don't need to hide
simple.
the framework.
Exactly. The whole idea.
Very simple torch commands.
It's a simple torch command. Yeah. And the idea is like, hey guys, if you guys want to train an AI model, like it doesn't take a massive team of people to do this. Here's a small code base that you can use to train an AI model on your computer in like 8 hours. That was the idea.
Yeah. It's a fantastic learning exercise. He's also behind AutoGrad, which did that same thing for doing like automatic gradient differentialization.
It's kind of like the Raspberry Pi of LLMs.
That's a good way to put it.
You know what I mean?
Also just fun guy. Has like a ton of these educational courses on YouTube.
I mean, I don't know the guy, but he seems like a chiller.
Yeah.
So he's known for his open source projects. Yes. On March 7th, he published a tweet. I saw this briefly. I didn't think too much of it just because he tweets a lot. But in the last week, it's gotten like, hundreds of thousands of impressions on Twitter, tons of likes. And it's this project called AutoResearch. And the idea here is basically to leverage the Agentic framework of LLMs and to apply them to the process of actually doing research on language models. So his whole take was basically, what if we could take an Agentic model and basically just prompt it to train a model overnight? So you give this agent, call it 12 hours of time. You tell it, here's a code base. I want you to basically just train this code base, train this model for the next 12 hours. Every time it improves in performance, I want you to basically just commit that model, that version of the code. And then I want you to try to keep improving upon that. So just keep incrementally trying to make more progress. He evaluated this model using something called validation bits per byte, which is basically a way of measuring something like the perplexity on some held out test set. And that was the whole thing. So he wrote this program.md markdown file, basically let his computer run for 12 hours. And what resulted was effectively a language model that had improved substantially in performance from the model that he had initially created, right? So it's not like he's starting from scratch. Like Carpathy is basically unleashing this auto research thing on some code that he had already written on an existing model. And the model basically self-improved itself from that point to get even better.
Yeah, so he basically had this baseline implementation that he wrote that was at 1.0. The next iteration of this that the model committed have the total batch size to 262K, so more steps. From there, it went to warm down, and you can kind of see this step graph getting lower and lower perplexity, which is good. We want to decrease perplexity until it got to experiment 80. Which is where it finally called it quits. And you can see kind of diminishing returns, but not consistently. Like there's some pretty big step changes from experiments like 40 to 45.
And it's cool because AutoResearch catches a lot of the failure modes that are involved in training language models. So when you're training a language model, one of like 100 things can go wrong, right? Like the model can run out of memory. There could be like shape mismatches in the tensors. Some of the gradients can explode. There can be like CUDA crashes, right? There's a ton of different things that can happen. The idea of AutoResearch is that you basically let the model introduce any change it wants, and it itself can catch any of these mistakes, revert back to a previous commit, and try something else, right? It's basically this way of just unleashing this AutoResearch agent to fully do whatever it wants. And if it messes something up, not a big deal. It can just go back in the Git history and start anew.
I think it's worth saying, though, that in this GitHub project, the project is just the code for the model. It's not the code for the harness, right? Like ostensibly he's using Codex or Claude Code to actually do this iterative improvement.
As the agent you're saying? Yeah, that's right. Yeah, exactly. So the target of this code is for this project called NanoChat. So again, NanoChat, NanoGPT, this is all in the family of these open source projects that Karpathy has released, which are just these minimal LLM training frameworks. And it's cool to see like all of the improvements that this made. As you said, it made basically 80 different improvements upon the source code. And again, it's important to say like this isn't starting from zero. This is starting from a source code that has already been vetted by Karpathy himself, an expert AI practitioner, right? So it goes to show that junior AI researchers, might be in trouble in the future if AutoResearch can really make all these improvements over the course of a 12-hour period.
Mm-hmm.
So, Piers, do you think that AutoResearch is like a tool for frontier AI development at this point? Or is this fundamentally more of like a small model efficiency, interesting research project, but that is mostly just a toy project?
Yeah, I mean, I feel like it seems like it's kind of optimizing on the margins, right? Because basically what Karpathy's done here is he's implemented like a minimum viable model, and then he's instructed some third party, like very frontier agent that's been trained on all of GitHub, all of the internet, to go out and tweak this simple model and then come back with its recommended changes. So I think like the net new thing here, as much as it is net new, is to say LLM research can be done in a similar way, which is namely that if you have a harness around the code that you're developing, that drastically improves the model's ability to optimize that because it gets feedback as it goes, right? Like models have gotten pretty good at being able to one-shot code that compiles, but the chances are it doesn't do exactly what you wanted it to do on the first pass. Like maybe a linting's wrong or maybe some unit tests aren't passing. So then it's the feedback from your testing harness that then gets fed back into the model, and the model can make tweaks based upon its input. And if it runs that enough times, usually it's able to clear through the unit tests that are failing. And that's what gave agentic development so much more power than just regular LLM development, where it just spits out some code and then you either use it or lose it, because it's getting that feedback that it knows kind of what it's doing and what it's not doing well. It seems pretty natural to me that actually this is a setting that would be pretty compatible with LLM development as well, because most of what we're doing when we're building models from scratch is we're saying, what are the current metrics? Okay, metrics are too high. Let's improve. Let's try to debug the current state of the model. Maybe look at some of the activations, see what's not working right, tweak the code, and then run some more experiments. This is actually exactly what OpenAI or Anthropic is trying to do with focusing on code as a way to get to AGI. Like the assumption was kind of, we need to have the ability to have self-improving AI models, and we do that through this feedback loop that is code. So the fact that this works on like some hand is not super surprising to me. What do you think?
I don't think it's that surprising. This is actually, I think, a little less interesting than what we were seeing with Barrett Zoff's work at Google in 2018 with this neural architecture search. I think Kwok Lee was also involved in this. Do you remember this? Mm-hmm. So the idea here was basically that you could train a network that could learn its own architecture by itself through basically a meta learning process. So the model would learn how to basically orchestrate its own architecture over the course of its learning process, which is crazy to think about that we were doing that in 2018. Mm-hmm. That's it. It didn't work, really. Like that's in some sense why we aren't really using.
Or at the very least, it didn't catch on.
It didn't catch on, but it didn't work mostly just because it's so hard to train these systems. But this is almost a version of that, right? This is not doing a neural architecture search. It's doing a neural training loop search almost, right? Where it's going through a whole training loop. And then it's almost doing like this evolutionary thing where it's picking the next thing that it thinks is most logical, trying that out. And if it doesn't work, reverting back. If it does work, kind of evolving on from there, right? It's almost akin to how biological evolution came about. So I think that this is interesting. I would love to see this applied to something a little bit more at the fringes of science, more a la neural architecture search, which was even more ambitious, I think, than this project. But there's nothing to say that we can't use this sort of methodology applied at the level of the actual architecture of the model. Because I think it's important to say what this is finding is basically these little tweaks to the training loop, to how the data is presented to the model, to the batch size of the data, to the, the learning steps, right? To the,
it could also
all
be
these different parameters.
No.
It could be, but it's
not just touching the config files, it's touching the whole code that runs as part of the training.
It's touching the whole code, but if I'm reading this correctly, I looked through some of the commits, I didn't see any crazy new change that the model made. So a crazy change would be to say, inventing a brand new architecture, right? Imagine if it came out with something that's
New like layer normalization.
like something crazy. Yeah, exactly. Something we've never seen before, right? That would be genuinely mind boggling that I can come up with this brand new architecture. But frankly, I don't think it's surprising that it hasn't done that because the way that these models are trained is they're trained to basically just ingest a bunch of technical reports. And in those technical reports, we report some of these common methods that we use to improve models. So when the model is suggesting improvements to the training loop, it's going to look back at its training data and basically just go almost chronologically through those and apply those to the current code base, right? It's almost going to say, okay, I saw in my training data that smaller batch sizes might be good, so let me try that. Didn't work. Okay, that's fine. I saw that in my training data, I saw this paper by OpenAI that looked at increasing the learning rate in this way. Let me try that. Okay, that worked, right? And so it's doing that basically. It's almost like regurgitating what it's seen, applying it, and going from there. But I think genuine creativity, and this is, I think, what research is in some sense, it's like a creative process, requires you to synthesize all this different information and propose something that is genuinely novel and at the fringes of science. And I don't think that this is doing it yet.
Yeah. Yeah. Well, I think it's actually hard at a very fundamental basis to train a model to do that, right? I think looking at things in a novel framing that maybe have been researched before, but just not in this domain. It's something that's proposed in like numerical theory or like physics, something that's like very, very other disciplinary, but can be moved into the ML space, I think is a little bit more tractable. But like, I think with software for a while, people were saying these machines are just regurgitating what they learned within their training phase. They're not actually capable of any of this deep insight, And then we started getting reasoning models where people were like, oh, it actually turns out that they can reason on novel problems. If we give them the inputs, they can step through things linearly that kind of approximates like math predicates or like formal logic. And now it's like, oh, maybe there's some element of creativity here. But like, I think what it boils down to me is exactly the intuition that you just stated, which is namely for a long time, I think, when people proposed new software applications to build, we kind of knew how to build them. Like there was enough precedent that I always used to say at my old job, if something is a question of engineering, the question that we should be asking ourselves is, do we have headcount that we can allocate to that thing? Because I guarantee you, if we can allocate the right headcount for it, we can get it done. Like it's a deterministic process.
As in, if it's been done before, you can do it again.
Or just really anything in software basically can be done. Like there are smart enough engineers that can build this software to do this thing. Like at this point, we kind of know that is solved. ML is one of these disciplines where we actually don't know if it can be solved until we solve it. I'm kind of reminded that like XKCD post where some project managers like, hey, can we improve this application to show where this photo was taken? And then the engineer's like, okay, great. I'll just grab the GPS data. It'll be like 2 days. And they're like, amazing. Can we also identify the birds that are captured in any of these shots? And they're like, I'll need a whole research team in 10 years.
Yeah.
You know what I mean? And like, that is kind of how it ends up being. It's just like, there are these elements of software that we just have these abstraction layers.
Totally.
And we're not training anything. We're kind of just like going through these rote steps of like taking a vision, transforming it into reality that we know how to do now. ML, it is research. Like we actually don't know how to do any of these things. And the corpus sizes are so small that actually are available online for novel model architectures. To me, it's like no real surprise that any pattern matching ML model wouldn't really be able to do something like this.
I agree with you. As you were speaking, I had this other insight, which is that I think that research is both creativity, but I would actually disagree with my earlier comment. I think it's also...
It's trying to back you up.
I appreciate that, but I actually think that in my own research process, research itself is a combination of creativity, as I said, and also the ability to search.
It's like shots at bat.
It's shots at bat, but fundamentally, at this point, there's been so much research done in so many different disciplines that when you're tackling a problem, chances are it's been maybe solved before in a different discipline, right? Like for instance, some of the methods that we're using, novel new methods that we're using in AI are actually somewhat old things from math or from econometrics, right? Or even from physics or from chemistry. But the reason that we haven't used them before is because making that link, finding that pattern or finding that insight is actually pretty tricky if you don't have access to all of those papers and you're not aware of all those papers.
And I guess that's kind of what I was suggesting, which is I think you could adapt things from other domains and then just apply them differently.
Exactly. Yeah.
Because the search space can be so much bigger.
And it can be done so much quicker, basically, by these tools. Yeah.
Exactly. So yeah, I guess there's maybe a question of like, what gradations of novelty do you really care about here? Do you care about something that's like brand new, or do you merely care about something that moves the needle? From what I've seen, I still haven't really see ML models be great at even that cross-domain generalization problem. I think it feels more tractable to me in some sense because it's like it has access to the corpora. It was trained on it. It can also do some sort of like RAG retrieval.
Right.
And the models just like aren't pulling it off right now for whatever reason. We're definitely going to need to solve that problem before we solve the further and more complex thing, which is like a model that actually has research taste.
Yeah, 100%.